Hello friends, now we'll start the new topics, derivative of parametric functions. Now in these topics, first of all we see the theorem which asked in the board exam frequently. Now let us start. The derivative of parametric functions. If two variables x and y are defined separately as functions or functions by intermediating variable t, then that intermediating variable is known as parameter. For example, x is equals to 80 square and y is equals to 280. These are the parameters of the parabola that you have learned in the 11th standard. The function relation between these two functions is that if we substitute x is equals to 80 square and y is equals to 280, then you will get LHS is equals to RHS. Now the important theorem which asked in the board exam. If x is equals to f of t, the meaning of this is that x is a function of t, y is equals to g of t. It means that y is a function of t are differentiable functions of t so that y is the differentiable function of x and if dx upon dt is not equals to 0, then dy by dx is equals to dy by dt upon dx upon dt. Its proof is given that x is equals to f of t and y is equals to g of t. X is a function of t, y is a function of t. Let there be a small increment in the value of t say delta t. Then delta x and delta y are the corresponding increments in x and y respectively As delta t, delta x, delta y are small increments in x and y respectively, such that delta t is not equals to 0 and delta x is not equals to 0, consider the incrementary ratio delta y upon delta x. And note that delta t is not equals to 0. Note that delta x tends to 0 implies that delta t tends to 0. That is, delta y upon delta x is equals to delta y upon delta t upon delta x upon delta t. Since delta x upon delta t is not equals to 0, taking the limit as delta t tends to 0 on the both sides, we get limit delta x tends to 0 delta y upon delta x is equals to limit delta t tends to 0 delta y upon delta t upon delta x upon delta t. As delta t tends to 0, delta x tends to 0, and the limit as delta x tends to 0 delta y upon delta x is equals to limit delta t tends to 0 for the numerator delta y upon delta t, and to the denominator limit delta t tends to 0 delta x upon delta t. Since x and y are differentiable functions of t, we have limit delta t tends to 0 delta x upon delta t is equals to dx upon dt, and delta t tends to 0 delta y upon delta t is equals to dy by dt exist, and are finite. Is number 2. From 1 and 2, we get limit delta x tends to 0 delta y upon delta x is equals to dy by dt upon dt. This is the third. Now the limit on the RHS exists, and limit on RHS exists, limit on LHS also exists. The RHS of the third exists and is finite, implies LHS of third also exists and finite. Therefore, limit delta x tends to 0 delta y upon delta x is equals to dy by dx. Thus, The equation third becomes dy upon dx is equals to dy by dt upon dx upon dt. This is the rule which asked in the board exam. Where dx upon dt is not equals to 0. Now next is illustrative examples. Find dy by dx if x is equals to 80 raised to 4 and y is equals to 280 square. X is equals to 4, y is equals to 280 square. Differentiate this with respect to t. Therefore, dx upon dt is equals to 4a t cube and dy upon dt is equals to 2at into 2. Therefore, dx upon dt is equals to 4at cube and dy by dt is equals to 4a. And that's why dy by dx is equals to dy by dt upon dx upon dt. Therefore, dy by dx is equals to 1 upon t square. Dy by dx is equals to 1 upon t square. Now, second example, x is equals to t minus root t, y is equals to t plus root t. Now, differentiate this with respect to x. Dx upon dt, derivative of t is 1 and derivative of root t is 1 upon 2 root t. And dy by dt, derivative of t is 1, derivative of root t is 1 upon 2 root t. Therefore, dy by dx, here must be x, and by mistake I had written here is a t. Therefore, dy by dt upon dx upon dt is equals to 1 plus 1 upon 2 root t upon 1 minus 1 upon 2 root t. Now simplify this. 1 into 2 root t, that is a 2 root t plus 1 upon 2 root t minus 1. And that's why dy by dx is equals to 2 root t plus 1 upon 2 root t minus 1. Third, x is equals to cos of log t, y is equals to log of cos t. Now differentiate this with respect to t. Dx upon dt is equals to minus sine of log of t upon derivative of log of t. Dy by dt is equals to 1 upon cos t into derivative of cos t is a minus sine t. Therefore, dx upon dt is equals to minus sine of log t upon derivative of log t is a 1 upon t. dy by dt here is it is a sin t upon cos t is a tan t, that is a minus tan t. Therefore, dy by dx is equals to dy by dt upon dx upon dt. That is a minus tan theta, tan t upon minus log of t upon t. Therefore, dy by dx is equals to plus t tan t upon sine of log of t. Next, x is equals to a in bracket theta plus sine theta, y is equals to a in bracket 1 minus cos theta. Now differentiate this with respect to theta. Dx upon d theta is equals to a in bracket 1 plus cos theta, dy upon d theta, a in bracket sine theta. And therefore, dy by dx is equals to a sine theta upon a in bracket 1 plus cos theta. This a get cancelled. Therefore, sine theta means 2 sine theta by 2 into cos theta by 2. 1 plus cos theta is a 2 cos square theta by 2. These 2 get cancelled. And you are getting sine theta upon 2 upon cos theta upon 2. And therefore, dy by dx is equals to tan of theta by 2. Fifth one, x is equals to in root of 1 minus t square and y is equals to sine inverse of t. Now differentiate this with respect to t. Dx upon dt is equals to 1 upon 2 in root of 1 minus t square into ddx of 1 minus t square. Derivative of this 1 is 0 and t square is a minus 2t. Again, dy by dt is 1 upon in root of 1 minus t square. Therefore, dy by dx is equals to dy by dx dt upon dx upon dt. And that is equals to 1 upon in root of 1 minus t square upon minus 2t upon 2 in root of 1 minus t square. And that is 1 upon in root of 1 minus t square into 2 root 1 minus t square upon minus 2t. These two get cancelled, 2 get cancelled, you are getting minus 1 upon t. Therefore, dy by dx is equals to minus 1 upon t. Next, find dy by dx. X is equals to a sec square theta, y is equals to tan cube theta. X is equals to sec square theta, y is equals to tan cube theta, at theta is equals to pi by 3. Now differentiate this with respect to theta. Dx upon d theta, derivative of sec square, that is a 2 sec theta into derivative of d d theta of sec theta, and dy by d theta, derivative of tan cube theta is a 3 tan square theta into d d theta of tan theta. Now what is the derivative of sec theta? Sec theta into tan theta. And what is the derivative of tan theta? Is a sec square theta. Therefore, dy upon dx is equals to dy upon d theta upon dx upon d theta. That is a 3 tan square theta into sec square theta upon 2 sec square theta into tan theta. Now sec square theta get cancelled. 1 tan theta get cancelled. Therefore, dy by dx is equals to 3 by 2 tan theta. At theta is equals to pi by 3, tan pi by 3 is root 3, and hence the dy by dx is equals to 3 root 3 upon 2. Next, x is equals to t plus 1 upon t, and y is equals to 1 upon t square at t is equals to 1 upon 2. Now differentiate this with respect to t. Derivative of t is 1 and 1 upon t is a minus 1 upon t square. Dy by dt, that is a, if we take this to the numerator, its power will become minus 2, and its a differentiation is a minus 2 t raised to minus 3, and the answer is minus 2 upon t raised to 3. Therefore, dy by dt is equals to minus 2 upon t raised to 3. Therefore, dx upon dt is equals to 1 minus t square, and dy by dt is equals to minus 2 upon t cube. Dy by dx is equals to minus 2 upon t cube upon 1 minus t square, and simplify this. At t is equals to 1 upon 2, then you will get minus 2 upon 1 upon 2 raised to 3, 1 minus 1 upon 2 raised to 2. Now this is the minus 2 upon 8, and here is a 1 minus 1 upon, that is a 4. 1 upon 2 bracket square means what? Here is 4. That is equals to minus 2 into 8, 1 minus 4, that is a minus 3. This minus minus become plus, and that is a 16 upon 3. Therefore, dy by dx is equals to, at t is equals to 1 upon 2, 16 upon 3. Next is third. X is equals to 3 cos t minus 2 cos cube t, and y is equals to 3 sin t minus 2 sin cube t. This is the drilling of the differentiation. To find out the derivative, you must know the formulas. Then and then you can understand these lectures. माझा या टॅबवर घेण्याचा उद्देश एकच की याच्या साहाय्याने तुम्हाला सर्व एक्झाम्पल्स इथे देता येतात. You can give all the examples. If I try to solve on the board, I will solve minimum 10 examples. But instead of that, you can learn this here. I am explaining step by steps, every step. Therefore here, differentiate this with respect to t, dx upon dt. What is the derivative of cos t? Is a minus sin t. What is the derivative of cos cube t? That is a 3 cos square t into derivative of cos t, which is the minus sin t. Okay. Next, minus 3 sin t plus 2 into 3, that is a 6 sin t into cos square t. Therefore, dx upon dt is equals to minus 3 sin t plus 6 sin t into cos square t. Now y is equals to 3 sin t minus 2 sin raised to 3t dy by dt. Derivative of sine is a cos. And now derivative of sine cube t is a 3 into 2. See this here? That is a 2 into 3, 6 sine square t, and derivative of sine t is a cos t. Therefore, dy by dx is equals to dy by dt upon dx upon dt. That is a 3 cos t minus 6 sine square t into cos t upon minus 3 sin t plus 6 sin t into cos square t. Now take the common 3 cos t, then in bracket you will get 1 minus 2 sin square t upon, take minus 3 sin t as a common or 3 sin t common, then in bracket you will get 2 cos square t minus 1, 3 get cancelled, cot t into 1 minus 2 sin square t means what? Cos of 2t, and 1 minus 2 sin square t means what? Cos of 2t, and 2 cos square t minus 1 means what? Again this is also cos of 2t. These two get cancelled and you are getting the answer, that is a cot t. Therefore dy by dx is equals to cot t. But at t is equals to pi by 6, and what is the cot of pi by 6? Is a root 3, and hence the answer is the root 3. Now the next example, if x square plus y square is equals to t plus 1 upon t, and x raised to 4 plus y raised to 4 is equals to t square plus 1 upon t square, then show that x cube y into dy by dx is equals to 1. Given that x raised to 4 plus y raised to 4 is equals to t square plus 1 upon t square. This is the first. and x square minus y square is equals to t minus 1 upon t square. Now squaring on both sides, then you will get, that is here is a plus sign, x square plus y square bracket square is equals to, plus sign here, is equals to t minus 1 upon t bracket square. If you expand it, then you will get x raised to 4 plus 2x square y square plus y raised to 4, and expansion of this t square minus 2, that is a 2 into t into 1 upon t. This tt get cancelled, you will get minus 2 plus 1 upon t square. Therefore x raised to 4 plus 2 x square y square plus y raised to 4. This is the t square plus 1 upon t square minus 2, and the value is equals to, this is the, what is the value of t square plus 1 upon t square? T square plus 1 upon t square is nothing but x raised to 4 plus y raised to 4 minus 2. Therefore here, if you see this here, x raised to 4 plus 2x square y square plus y raised to 4. And what is here? X raised to 4 plus y raised to 4 minus 2. These terms get cancelled. Then here you will get 2 x square y square is equals to minus 2. Now differentiate this with respect to x. Then you will get, that is a 2x y square plus x square, derivative of y square is a 2y into dy by dx is equals to 0. Now these 2 get cancelled. Here is xy and xy. Take the term, that is a 2x square y into dy by dx is equals to minus 2xy square. Therefore dy by dx is equals to minus 2xy square upon 2x square y. And that's why you will get again, that is a dy by dx is equals to, this 2 get cancelled, minus x into 1 upon x square and x square y. Therefore its value is dy by dx is equals to minus, that is minus will become plus 1 upon x cube y. Therefore x cube y into dy by dx is equals to 1. This is we have proved. Now see this again, x raised to 4 plus y raised to 4 is equals to t square plus 1 upon t square. X square minus y square is equals to t minus 1 upon t, plus here sign must be there, and squaring on both sides, then you will get, that is x raised to 4 plus 2 x square y square plus y raised to 4 is equals to t square minus 2 plus 1 upon t square. Therefore x square, x raised to 4 plus 2 x square y square plus y raised to 4 is equals to t square plus 1 upon t square minus 2, and this value of this t square plus 1 upon t square is x raised to 4 plus y raised to 4 minus 2. These two terms get cancelled. You are getting x square y square is equals to minus 1. Differentiate this, normal differentiation here is, therefore you will get dy by dx is equals to minus 2x y square upon 2x square y. Now again here is a one term is written as minus, this is x. What is the value of y square? Y square is a minus 1 upon x square, and that's why here is a minus 1 upon x square. And after simplification, this x get cancelled, you will get plus 1 upon x cube y, and hence this is the proof. Now the next is, if x is equals to a in bracket t minus 1 upon t and y is equals to b in bracket t plus 1 upon t. Then show that dy by dx is equals to b square x upon a square y. Given that x is equals to a in bracket t minus 1 upon t and y is equals to b in bracket t plus 1 upon t. That's why x upon a is equals to t minus 1 upon t, 1. Y upon b is equals to t plus 1 upon t. This is the second. Square of 1 minus square of 2 gives, and this is nothing but the equation of the ellipse. X square upon a square minus y square upon b square is equals to t minus 1 upon t bracket square minus t plus 1 upon t bracket square. Now evaluate this. T square minus 2 plus 1 upon t square minus t square minus 2 minus 1 upon t square. Therefore x square minus a square minus y square upon b square is equals to plus t square minus t square get cancelled, 1 upon t square minus 1 upon t square, minus 2 and minus 2 that become plus. Therefore x square upon a square minus y square upon b square is equals to minus 4. Now here is a 1 upon a square, derivative of x square is a 2x. Y square is a 2y upon b square into dy by dx is equals to 0. Now here 2 get cancelled, 2x upon a square, 2y upon b square, dy by dx is equals to 0. Therefore 2y upon b square into dy by dx is equals to 2x upon a square. Therefore dy by dx is equals to b square x upon a square y. And this is we want to prove. Dy by dx is equals to b square x upon a square y. This is in the textbook, you can see this also. Fifth one, if x is equals to in root of sine inverse of t and y is equals to in root of cos inverse of t, then show that dy by dx is equals to minus y upon x. Given that x is equals to sine inverse of t and y is equals to in root of a raised to cos inverse of t. Now differentiate this with respect to t. Therefore, you will get d dt of in root of a raised to sine inverse of t, that is equals to 1 upon 2 in root of a raised to sine inverse of t into d dt of a raised to sine inverse of t. What is the derivative of a raised to sine inverse of t? That is 1 upon 2 in root of a raised to sine inverse of t. Derivative of a raised to sine inverse of t is a raised to sine inverse of t into log of a into derivative of sine inverse of t, which is 1 upon 1 minus t square. Therefore, a raised to sine inverse of t log of a upon 2 in root of a raised to sine inverse of t into 1 upon in root of 1 minus t square. Now y is equals to in root of a raised to cos inverse t. Therefore, dy by dt is equals to 1 upon 2 a raised to cos inverse t into ddt of in root of, that is the derivative of a raised to cos inverse of t. That is the 1 upon 2 a raised to cos inverse of t into a raised to cos inverse of t into log of a into derivative of cos inverse of t is a minus 1 upon in root of 1 minus x square, 1 minus t square. And therefore, a is the root of this quantity and here the power is 1. Therefore, minus a raised to cos inverse of t upon 2 in root of a raised to cos inverse of t log of a into 1 upon in root of 1 minus t square. This is nothing but the 2. Next is a dy by dt is equals to minus in root of a raised to cos inverse of t into log of a upon 2 in root of 1 minus t square. That is a minus y log of a upon 2 in root of 1 minus t square. Therefore, dy by dx is equals to minus y log of a upon 2 in root of 1 minus t square whole divided by x log a upon 2 in root of 1 minus t square. And if you simplify this, then you will get minus y upon x. Therefore, dy by dx is equals to minus y upon x. All the examples are complicated. You have to do more and more practice. Then you will have the perfectness. Now the next. These are also very famous problems which asked in the board exam. Differentiation of one function with respect to another. If y is differentiable function of x, then the derivative of y with respect to x is dy by dx. Similarly, if u is equals to f of x, v is equals to g of x, differentiable function of x such that du by dx is equals to f dash of x and dv by dx is equals to g dash of x, then the derivative of u with respect to v is du by dv upon du upon dx whole divided by dv by dx, and that is equals to f dash of x upon g dash of x. Now the illustrative examples. Find the derivative of 7 raised to x with respect to x raised to 7. Let u is equals to x raised to 7 raised to x and v is equals to x raised to 7. See this 7 raised to x, x raised to 7. One is a exponential, another is a algebraic. That is the derivative of 7 raised to x is 7 raised to x into log of 7, and the derivative of x raised to 7 is 7x raised to 6. Therefore, our required derivative du by dv is equals to 7 raised to x into log of 7 upon, that is a du by dx upon dv by dx, 7 raised to x log of 7 upon 7x raised to 6. Find the derivative of cos inverse of x with respect to in root of 1 minus x square. Let u is equals to cos inverse of x. V is equals to in root of 1 minus x square. Now differentiate this with respect to x. Therefore, du by dx is equals to minus 1 upon in root of 1 minus x square. And dv by dx is equals to 1 upon 2 in root of 1 minus x square into derivative of 1 minus x square. The derivative of 1 is 0 and the x square, which is 2x, that is nothing but the minus 2x will be there because minus sign. Therefore, du by dv is equals to du by dx upon dv upon dx. That is the minus 1 upon in root of 1 minus x square minus in root of 1 minus x square. Minus minus will become plus, that is 1 upon x. Next is find the derivative of tan inverse in root of 1 plus x square minus 1 upon x with respect to sine inverse of 2x upon 1 plus x square. Now u is equals to tan inverse in root of 1 plus x square minus 1 upon x, and v is equals to sine inverse in bracket 2x upon 1 plus x square. Then we have to find du by dv Now u is equals to tan inverse in bracket in root of 1 plus x square minus 1 upon x. Put x is equals to tan theta. Theta is equals to tan inverse of x. This is the substitution that we have seen, this type of the substitution. U is equals to tan inverse in root of 1 plus tan square theta minus 1 upon tan theta. That is the 1 plus tan square theta is the sec square theta. Square and root get cancelled. You will get sec theta minus 1 upon tan theta. Therefore, u is equals to tan inverse. Sec means what? 1 upon cos theta minus 1 upon tan theta. And that is a tan inverse of, that is a 1 minus cos theta upon tan theta into cos theta, because this was the cos here. Therefore, u is equals to tan inverse 1 minus cos theta upon this tan theta into cos theta means cos get cancelled, you will get sin theta. Therefore, u is equals to tan inverse. That is a 2 sin square theta upon 2 sin theta by 2 into cos theta by 2. And that's why in bracket you will get u is equals to tan inverse sin theta by 2 upon cos theta by 2. That is a tan inverse of tan of theta by 2. Tan inverse of tan of theta by 2. And that is a final is theta by 2. Therefore, what is a theta? Theta is a tan inverse of x. Now you cannot differentiate this with this. You can also, but in problem we have given the value of theta. I had done directly this. Now next is v is equals to sine inverse in bracket 2x upon 1 plus x square. X is equals to sine theta. Theta is equals to tan inverse of x. That is a sine inverse in bracket 2 tan theta upon 1 plus tan square theta. That is a sine inverse of sine of 2 times theta. Now we have the variables, that is v is in theta, u is also in theta. Also we can differentiate, no problem. That is a, here we have to change it. That is 1 upon 2 tan inverse of x, their differentiation. That is the du by dx is equals to 1 upon 2 in 1 upon 2 1 plus x square. Put sign get cancelled. 1 upon 1 plus x square. Differentiate with respect to again theta. Again I am making a mistake. There is a mistake by me. This is 1 upon 2 upon 1 upon 2. Therefore, du by dv, that is equals to 1 upon 4. If you have the variable and it doesn't matter if there is no change in the answer. Exercise 1.4, if there is change, you can change it. First, find dy by dx. If x is equals to 80 square, y is equals to 280. Therefore, dx upon dt is equals to 280. dy upon dt is equals to 2a, derivative of t is 1. Therefore, dy by dx is equals to dy by dt upon dx upon dt. That is a 2a upon 280, that is 1 upon t. The last solve examples you solve using putting the value of theta, then you will get the answer. Therefore, dy by dx is equals to 1 upon t. Now see this answer. It's from the first question. X is equals to 80 square, y is equals to 280. dx upon dt is 280, 2a. Take the ratio. You will get dy upon dt is equals to 1 upon t. X is equals to cot theta, y is equals to b cosec theta. Just we have to complete this. Next is second. X is equals to a cot theta, y is equals to b cosec theta. Now differentiate with respect to theta. Dx upon d theta is equals to minus a cosec square theta. Dy upon d theta is equals to minus b cosec theta into cot theta. Therefore, dy by dx is equals to dy by d theta upon dx upon d theta. That is a minus b cosec theta into cot theta upon minus a cosec square theta. Minus minus become plus b upon a cot theta upon cosec theta. Therefore, dy by dx is equals to b upon a cos theta upon sin theta into sin theta. Sin theta get cancelled. Dy by dx is equals to b upon a cos theta. Now the next is now see this again here. This is the x is equals to their derivatives dy upon dx. I have taken their ratios. Minus minus become plus b upon a cot theta upon cosec theta. B upon a cot means cos upon sin. Cosec means that is a sin theta. Therefore, you will get the answer. Dy by dx is equals to b upon a cos theta. Third, x is equals to in root of a square plus m square. Y is equals to log of a square plus m square. Now differentiate this with respect to m. Dx upon dm is equals to 1 upon 2 in root of a square m square into derivative of m square. is 2m. Derivative of a square is 0. Derivative of a square is here is 0, and the dy upon dm, that is 1 upon a square plus m square into derivative of a square plus m square. Derivative of a square is 0 and m square is at 2m. See this here. Dy by dx is equals to m upon in root of a square plus m square, and dy by dm is equals to m upon 2m upon a square plus m square. Therefore, dy by dx is equals to dy by dm upon dx upon dm. That is a 2m upon a square plus m square upon m upon in root of a square plus m square. That is a multiplied and reciprocal, then you will get dy by dx is equals to 2m upon a square plus m square into in root of a square plus m square upon m. This m get cancelled. Then you will get 2 upon in root of a square plus m square. Therefore, dy by dx is equals to 2 upon in root of a square plus m square. Now see this again here. This is one side. Their derivatives, ratio, these are the derivatives, 2m upon a square plus m square upon m upon in root of a square plus m square. Get cancelled, you will get 2 upon in root of a square plus m square. Therefore, dy by dx is equals to 2 upon in root of a square plus m square. Next is fourth one, x is equals to sine theta, y is equals to tan theta. Very simple question. Differentiate this with respect to theta. The derivative of sine theta is cos theta. Dx upon d theta is equals to cos theta. Derivative of tan theta is a sec square theta. Therefore, dy by dx is equals to dy by d theta upon dx upon d theta, that is a sec square theta upon cos theta. That is a sec cube theta. Now, how that sec cube comes? That is a 1 upon cos. 1 upon cos becomes sec theta, and it becomes sec cube theta. Therefore, dy by dx is equals to sec cube theta. Now, we will take the direct next. X is equals to a in bracket 1 minus cos theta, y is equals to b in bracket theta minus sin theta. Now differentiate this with respect to theta. Dx upon d theta is equals to a. Derivative of 1 is 0. Cos theta is a minus sin theta. This minus minus become plus. Dy by d theta b. Derivative of theta is 1. Derivative of sin theta is a cos theta. Therefore, dy by dx is equals to dy by d theta upon dx upon d theta. That is equals to b in bracket 1 minus cos theta upon a in bracket sin theta. And therefore, dy by dx is equals to b upon a 1 minus cos theta is a 2 sin square theta by 2 upon 2 sin theta by 2 into cos theta by 2. Now these two get cancelled. Sin of theta by 2 cos sin of theta by 2 get cancelled. Therefore, b upon a, that is nothing but the tan of theta by 2. And that's why dy by dx is equals to b upon a. This is the tan of theta by 2. See this again here. these two examples. Last example was the x is equals to sin theta, y is equals to tan theta, their derivatives, and the answer. Now just this example, dx upon d theta, a, derivative of 1 is 0, cos theta is minus sin theta. This minus minus become plus a sin theta, and dy by d theta, b, derivative of theta is 1, derivative of sin theta is a cos theta, and that's why dy by dx is equals to dy by d theta upon dx upon d theta, b in bracket 1 minus cos theta, a in bracket sin theta. But what is the 1 minus cos theta? Is a 2 sin square theta by 2, and sin theta is a 2 sin theta by 2 into cos theta by 2. 1 sin theta by 2 get cancelled. That is the dy by dx is equals to b upon a into tan of theta by 2, and that's why b upon a into tan of theta by 2. Now the next is sixth one. X is equals to t plus 1 upon t bracket raised to a, and y is equals to a raised to t plus 1 upon t. Therefore, x is equals to t plus 1 upon t raised to a, and y is equals to a raised to t plus 1 upon t. Now differentiate this with respect to t. Dx upon dt, that is a t plus 1 upon t raised to a minus 1 into ddt of t plus 1 upon t. At the same time, dy by dt, a raised to t plus 1 upon t, its a derivative is a raised to t plus 1 upon t into log of a into ddt of t plus 1 upon t. Derivative of t is 1, and 1 upon t is a minus 1 upon t square. Therefore, dx upon dt is equals to a t plus 1 upon t raised to a minus 1, derivative of t is 1, 1 upon t is a minus 1 upon t square, dy by dt is equals to a raised to t plus 1 upon t log of a, 1 minus 1 upon t square. Therefore, dy by dx is equals to dy by dt upon dx upon dt. That is a raised to t plus 1 upon t into log of a into 1 minus 1 upon t square upon a into t plus 1 upon t raised to minus 1. This bracket raised to minus 1. 1 minus t square numerator going to get cancelled. See this here. Next is a raised to t plus 1 upon t a raised to 1 t plus 1 upon t raised to this bracket raised to a minus 1 log of a. Therefore, a raised to t plus 1 upon t minus 1. Here, this is the a raised to 1. Therefore, a raised to t plus 1 upon t minus 1 into log of a. Therefore, dy by dx is equals to a raised to t plus 1 upon t minus 1 into log of a upon t plus 1 upon t bracket raised to a minus 1. Now see this again. If you want to write down this example, you can write down. I am showing only this example by scrolling the screen. Now the next. X is equals to cos inverse in bracket 2t upon 1 plus t square, y is equals to sec inverse in root of 1 plus t square, x is equals to cos inverse in bracket 2t plus 1 upon t square, y is equals to sec inverse in bracket in root of 1 plus t square. Now put here x is equals to, t is equals to tan of theta, and theta is equals to tan inverse of t. Therefore, you will get cos inverse in bracket 2 tan theta upon 1 plus tan square theta, and y is equals to sec inverse in root of 1 plus t square, 1 plus tan square theta. Substitute that is t is equals to tan theta. Therefore, you will get cos inverse 2 tan theta upon 1 plus tan square theta. 1 plus tan square theta is a sec square theta. And y is equals to sec inverse. What is here? That is y is equals to sec inverse in root of 1 plus tan square theta is a sec square theta. Square root get cancelled. You will get sec theta. That is sec inverse of sec theta is theta. And what is here? Cos inverse. That is a 2 tan theta upon sec square theta. This sec square will become cos square theta. That is sin theta upon cos theta into cos square theta. One cos get cancelled. Then you will get cos inverse in bracket 2 sin theta into cos theta. Now see this here. That is a 2 tan theta into cos square theta. This sec square will become cos square. And y is equals to theta. Sec inverse of sec theta is theta. Now simplify this. This 2 tan theta means what? Sin theta upon cos theta into cos square theta. One cos get cancelled. Then you are getting 2 sin theta into cos theta. But what is a 2 sin theta into cos theta? Sin of 2 times theta. And cos inverse of sin of 2 times theta. Now here is a sin theta. Will require the cos theta. Therefore, convert this sin of 2 times theta. That is equals to cos of pi by 2 minus 2 theta. Therefore, x is equals to cos inverse of in bracket cos of pi by 2 minus 2 theta. And what is the cos inverse of cos of theta? This is the pi by 2 minus 2 theta. Now substitute the value of theta. Y is equals to theta. Again, we can differentiate here with respect to theta, no problem. Theta is not there present. Therefore, dx upon d theta is equals to minus 2 and dy upon d theta is equals to 1. Sometimes it is possible when there is not the power of theta. After differentiating, you are getting the constant. That is the dx upon d theta is a minus 2. Therefore, instead of putting that value of the theta, we can get the answer in the same way. Therefore, dy by d theta is equals to 1, and that's the answer is dy by dx is equals to dy by d theta upon dx upon d theta. That is equals to minus 1 upon 2, and hence the answer is a minus 1 upon 2. Now, if you want to write, then write this from the board. I am scrolling this only. Therefore, dy by dx is equals to minus 1 upon 2. Now the next example. Eighth example. X is equals to cos inverse in bracket 4t cube minus 3t. Y is equals to tan inverse in root of 1 minus t square upon t. Now put here, that is a cos. This is the cos, that is 4 cos cube theta minus 3 cos theta. T is equals to cos theta. Theta is equals to cos inverse of t. हे केव्हा जमणार आहे तुम्हाला की नंबर ऑफ द टाइम्स तुम्ही जेव्हा प्रॅक्टिस कराल देन यू विल अंडरस्टँड what type of the proper substitution is there. Therefore, x is equals to cos inverse in bracket 4 cos cube theta minus 3 cos theta. Y is equals to tan inverse in root of 1 minus cos square theta upon cos theta. Therefore, x is equals to cos inverse, that is a cos of 3 theta, and y is equals to, see this here, 1 minus cos square theta is a sin square theta, square and root get cancelled. You will get sin theta upon cos theta. Therefore, cos inverse of cos of 3 theta is a 3 theta, and y is equals to tan inverse of tan of theta is a theta. Therefore, x is equals to 3 theta and y is equals to theta. Again, we have the theta. We can differentiate this with respect to theta. Dx upon d theta is 3 and dy upon d theta is 1. And that's why dy by dx, the required derivative, dy by dx is equals to dy by d theta upon dx upon d theta. That is a 1 upon 3. This is dy by dx is equals to 1 upon 3. Also see this, the same, if you want to write. From the board you can write. I will scroll down this only. Dy by dx is equals to 1 upon 3. Now the next is question number 2. Find dy by dx if x is equals to cosec square theta, y is equals to cot cube theta, and theta is equals to pi by 6. Now differentiate this with respect to theta. Dx upon d theta cosec square, that is a 3 cosec theta into, which is a minus, into derivative of cosec theta. Now see this here, that is a, sorry, 2 cosec theta into derivative of cosec theta is a minus cosec theta into cos theta. That's why here is minus sign. Again dy upon d theta, it is a 3 cot square theta. That will be the 3 cot square theta into derivative of cot square theta, which is minus cosec square theta, which is minus cosec square theta. Now see this here, that is 3 cot square theta, derivative of cot square theta is a minus cosec square theta. Therefore dy by dx is equals to dy by d theta upon dx upon d theta. That is a minus 3 cot square theta into cosec square theta upon minus 2 cosec theta into cosec theta, and that is the cosec square theta into cot theta. Now the terms will get cancelled. You will get 3 by 2 cot theta, 3 by 2 into cot theta. And this is the answer. Minus minus will become plus 3 by 2. At theta is equals to pi by 6, and cot of pi by 6 is equals to root 3. Therefore dy by dx is equals to 3 root 3 upon 2. Now see this again. You can write down from this board. I will scroll down this. Therefore dy by dx is equals to 3 root 3 upon 2. Now the next example. X is equals to a cos cube theta, y is equals to a sin cube theta. Theta is equals to pi by 3. Now differentiate this with respect to theta. Dx upon d theta is equals to a 3a cos square theta into derivative of cos theta is a minus sin theta. Dy upon d theta is equals to a 3a sin square theta into derivative of sin theta, which is the cos theta. Now take the ratio. Therefore dy upon dx is equals to dy upon d theta upon dx upon d theta, and that is equals to 3a sin square theta into cos theta upon 3a cos square theta into minus sin theta. Now 3a 3a get cancelled. 1 cos 1 sin will get cancelled, and then you will get minus tan of theta. This is answer, minus tan theta. But it is at theta is equals to pi by 3. Okay. Theta is equals to, it is a pi by 3. Therefore tan of pi by 3, that is equals to root 3, and hence dy by dx is equals to minus root 3. Now write down from the board. Number of the students say that you want to write this. Now you can write. Therefore dy by dx at theta is equals to pi by 3 is equals to minus root 3. Now the next is third one. X is equals to t square plus t plus 1. Y is equals to sin of pi t upon 2 plus cos of pi t upon 2 at t is equals to 1. Now differentiate this with respect to t. Dx upon dt is equals to 2t, derivative of t square is 2t, derivative of t is 1, 1 is 0. and dy by dt, that is the derivative of sine of pi t upon 2 is a cos of pi t upon 2 into ddt of pi t upon 2. Now what is the derivative of cos of pi t upon 2? It is a minus sine of pi t upon 2 into ddt of pi t upon 2, which is pi by 2. Because the derivative of t is 1, here is the derivative of t is 1. That is a minus sine of pi t upon 2 into ddt of pi t upon 2. Therefore, dx upon dt is equals to 2t plus 1. dy upon dt is equals to pi upon 2 cos of pi t upon 2 minus pi upon 2 sine of pi t upon 2. Therefore, dy by dx is equals to pi by 2 cos of pi t upon 2 minus sine of pi t upon 2 upon 2t plus 1 dy by dx at t is equals to 1 pi by 2 cos of pi t upon 2, that is the t is equals to 1 cos of pi by 2 minus sine of pi by 2, that is a 2t plus 1, that is a 2 into 1 plus 1, that is a 2 plus 1. Now what is the cos 90 is 0, that is a pi by 2 into that term will become 0, and here is a pi by 2 sine of pi by 2, that is 1, which is minus pi by 2 upon 2 plus 1, which is 3, that is minus pi by 2 upon 3 multiplied and reciprocally to become minus pi by 6. Sorry, minus pi by 4, pi by 2 into 1 upon 2, that is 1 plus 2. 1 plus 2 is 3, that is a minus pi by 6. Again, once again, sorry. Now see this answer. I will scroll down. You can write down the answer. Now here is a minus pi by 2 into 1, that is a, and 2 plus 1, that is a 3, that is a minus pi by 6. Now the next is x is equals to 2 cos t plus cos of 2t y is equals to 2 sin t minus sine of 2t at t is equals to pi by 4. Now differentiate this with respect to t. This is x and y. Therefore, dx upon dt is equals to minus 2 sin t. That is the derivative of cos t. See this here. Derivative of cos t is a minus sin t, and derivative of cos of 2t is a minus sine of 2t into derivative of these 2t. Derivative of t is 1. That is a 2 into 1. 2. And here is a 2. dy by dt, that is a 2. Derivative of sine of t, which is a cos t. and derivative of sine of 2t is a cos of 2t into derivative of 2t is again 2. And that's why dy by dx is equals to dy by dt upon dx upon dt. That is a 2 cos t minus 2 cos of 2t minus 2 sin t minus 2 sin of 2t. Therefore, dy by dx is equals to cos t minus cos of 2t upon minus sin t minus sin of 2t at t is equals to pi by 4. That is the cos of pi by 4 is again 1 by root 2. Cos of pi by 4 is 1 by root 2. Cos of 2 into pi by 4 means what? Cos of pi by 2 and cos of pi by 2. This will become 90. That will become 0. Sin of pi by 4. That is sin of pi by 4 is 1 upon root 2. And sin of 2 into pi by 4 means what? Sin of pi by 2. Sin of pi by 2 is 1. Now see this here. Therefore, you will get cos of pi by 4. That is the cos of pi by 4 minus this 2 get cancelled. You will get cos of pi by 2 minus sin of pi by 4 minus sin of pi by 2. Substitute the values. Cos of pi by 4, that is 1 by root 2. Cos of pi by 2, that is a cos 90 0. Sin of pi by 4 is again here is 1 by root 2, that is minus 1 upon root 2. And sin of pi by 2, which is 90, that is 1. And that's why 1 by root 2. Take the minus sign as a common. I think that I will show you again how the answers comes. Therefore, now see this again. I had some doubt about it, but okay. Now here is a 1 upon root 2. You can write down now. I will explain the last step only. Now see this simplification. Here is a 1 upon root 2. Okay. Minus 1 upon root 2 minus 1. What is happening here? Here is a 1 upon root 2. And if we simplify this, that is a minus 1. Take minus sign as common. That is a minus 1 plus root 2 upon root 2. That numerator having 1 root 2 to the denominator, and the denominator having 1 root 2, it's a denominator. That root 2 get cancelled. That I had not shown here. This root 2, I forget to write here this root 2. That root 2 get cancelled. Then multiplied numerator and the denominator. Rationalize this denominator. That is multiplied it with 1 minus root 2. Then you will get 1 minus 2 minus in bracket 1 minus root 2 and simplify it. It's a minus 1 and this minus minus will become plus. That is you will get 1 minus root 2. This is the dy by dx at t is equals to pi by 4. Next is fifth one, x is equals to t plus 2 sine of pi t, y is equals to 3t minus cos of pi t at t is equals to 1 upon 2. Now differentiate this with respect to t. Now dx upon dt. What is the derivative of this t? Derivative of t is 1. What is the derivative of sine of pi t? Derivative of sine of pi t is a pi t into derivative of pi t. Derivative of t is 1, that is into pi. That is the cos of pi t into pi. Next is, what is the derivative of 3t? Derivative of t is 1, that is a 3 into 1. That is a 3. Cos of pi t. That is the derivative of cos of pi t is a minus sine of pi t. That then minus minus will become plus into derivative of this pi t. Again derivative of that t is 1 into pi. Therefore, 1 plus 2 cos of pi t into pi dy by dt, that is a 3 plus sine of pi t into pi. Therefore, dy by dx is equals to 3 plus sine of pi t into pi upon 1 plus 2 pi cos of pi t at t is equals to 1 upon 2. That is a t is equals to 1 upon 2. Substitute the value of t is equals to 1 upon 2. What will happen here? This is a 3 plus pi sine of pi t is equals to 1 upon 2. That is sine of pi by 2 upon 1 plus 2 pi cos of t is equals to 1 upon 2. That is a cos 90. This cos 90 will become 0. This will become sin 90 is 1. That is a 3 plus pi upon 1 because cos 90 will become 0. Now see this answer. That is a 3 sine of pi by 2 upon 1 plus 2 pi cos of pi by 2. That is a 3 plus pi sine of 90 is 1 and 1 plus 2 pi. This is the cos of pi by 2 and becomes 0. Now 3 plus pi upon 1, 2 pi to 0. That is 3 plus pi. That will be the answer. That is answer. That is 3 plus pi. This is the answer. Now see this again. I will scroll down. You can write this. This is a sin pi by 2 is 1, cos pi by 2 is 0. This becomes pi, 0, 3 plus pi upon 1 and this is answer 3 plus pi. Next is if x is equals to question number 3, x is equals to a in root of sec theta minus tan theta and y is equals to a in root of sec theta plus tan theta. Then show that dy by dx is equals to minus y upon x. Dy by dx is equals to minus y upon x. x is equals to a in root of sec theta minus tan theta. Y is equals to in root of sec theta plus tan theta. Now dx upon d theta is equals to dx upon d theta is equals to 1 upon, this is the root sign, its a derivative will be, that is a 1 upon 2 in root of sec theta minus tan theta into ddx of sec theta into tan theta. See this here, into a dd theta of sec theta minus tan theta. Therefore dx upon d theta is equals to a derivative of sec theta is a sec theta into tan theta is a sec square theta upon 2 in root of sec theta minus tan theta. Now take sec theta as a common, then you will get sec theta, that is a, if you take minus sec theta common, then in bracket you will get sec theta minus tan theta upon in root of sec theta minus tan theta. This is a power 1 and this is a root. You see this here, sec theta minus tan theta upon in root of sec theta minus tan theta. Here is a power 1, here is a half. Therefore you will get dx upon d theta is equals to minus a upon 2 sec theta into root of sec theta minus tan theta. This is a dx upon d theta minus a by 2 sec theta in root of that is nothing but the x. Next is y is equals to in root of sec theta plus tan theta. It's a differentiation dy by d theta. That is a upon 2 times root of sec theta plus tan theta into derivative of sec theta plus tan theta, which is sec theta into tan theta, and derivative of tan theta is a sec square theta. Now take the sec theta is common, then in bracket you will get tan theta plus sec theta. Here is a root sign and 1 power, therefore you will get 1 upon 2 a sec theta in root of sec theta plus tan theta. Therefore dy by d theta is equals to 1 upon 2 sec theta into y, and that's why you will get very simple answer. Dy by dx is equals to 1 upon 2 sec theta into y, this is, and dx upon d theta is minus x upon 2 into sec theta. Therefore dy by dx is equals to minus y upon x. Dy by dx, by mistake here is a theta, but dy by dx is equals to minus y upon x. Here is a x. Now I'll scroll down, you can write down this. You can write down now. Therefore dy by dx is equals to minus y upon x. Now the next is second, if x is equals to e raised to sine 3t, y is equals to e raised to cos of 3t. Then show that dy by dx is equals to minus y log x upon x log of y. Now x is equals to e raised to sine of 3t, y is equals to e raised to cos of 3t, log of x is equals to sine of 3t, log of y is equals to cos of 3t. Now here log of x square plus log of y square, that is the important formula. Sine square theta plus cos square theta is equals to 1. That is the log of x square plus log of y square. That is sine 3 theta bracket square plus cos 3 theta bracket square, that is equals to 1. And then differentiate now. Log of x bracket square plus log of y bracket square is equals to 1. Differentiate this with respect to x, that is the 2 log of x into derivative of log of x is 1 upon x, plus 2 log of y into derivative of log of y is 1 upon y, that is the ddx of log of y. Therefore 2 log of x, derivative of log of x is 1 upon x, 2 log of y, derivative of log of y is 1 upon y into dy by dx, that is equals to 0. These two to get cancelled overall. Therefore log of x upon x plus log of y upon y, that is equals to 0. This is. Now next simplify. Dy by dx is equals to minus log of x upon x into y upon log of y. Again see this one more step. That is dy by dx is equals to minus log of x upon x into, this is the y and this is the log of y. Therefore dy by dx is equals to minus y log x upon x log y. Dy by dx is equals to minus y log x, y upon x into log of x upon log of y. Hence proved. Now see this again. I will scroll down, you can write down this. This is very important, log of x square plus log of y square is equals to 1. And then differentiate. Derivative of log of x, log of y. Therefore, dy by dx is equals to minus y upon x into log of x upon log of y, and hence it is a proof. Next is if x is equals to t plus 1 upon t minus 1, y is equals to t minus 1 upon t plus 1, then y square plus dy by dx is equals to 0. Then show that y square plus dy by dx is equals to 0. X is equals to t plus 1 upon t minus 1. Y is equals to t minus 1 upon t plus 1. Now differentiate this with respect to t. Dx upon dt is equals to, use the quotient rule, t minus 1 into ddt of t plus 1 minus t plus 1 into ddt of t minus 1 upon t minus 1 bracket square. Now see this here. Derivative of t is 1. Derivative of 1 is 0. Derivative of t is 1. Then what you will get? T minus 1 into 1 minus t plus 1 into 1 upon t minus 1 bracket square. Now see this here. T minus 1 minus in bracket t plus 1 upon t minus 1 bracket square. Now open the bracket. Dx upon dt is equals to, this plus t minus t get cancelled. If we open the bracket, you will get minus t. And this is a plus t. Plus t minus t get cancelled. This is a minus 1 and minus 1, that is a minus t plus t only. It's not t there. Okay, we will see here by mistake saying that. That is a y is equals to t minus 1 upon t plus 1. I will change it shortly. That is the dy by dt. Again apply the quotient rule. T plus 1 into ddt of t minus 1 minus t minus 1 into ddt of t plus 1 upon t plus 1 bracket square. Therefore dy by dt is equals to t plus 1 minus t minus 1 bracket complete. That is 2 upon t plus 1. 2 upon t plus 1 bracket square. Therefore dy by dx is equals to dy by dt upon dx upon dt. Now I will cut there 2. That is a 2 upon 1 plus t square upon I think that it is a mistake. Now I will scroll down. I had corrected it. X is equals to y is equals to. Differentiate this with respect to t. Apply the quotient rule. Now here is only the minus 2 upon t minus 1 bracket square. And here is also, I had corrected it. That is a 2 upon 1 plus t square upon minus 2 upon 1 minus t bracket square. Therefore dy by dx is equals to minus 1 minus t square upon 1 plus t square. But the next is squaring on both sides. Therefore you will get, that is y square plus dy by dx. But what is the y square? Y square is a t minus 1 bracket square upon t plus 1 bracket square. And what is the dy by dx? The dy by dx is a minus t minus 1 bracket square upon t plus 1 bracket square. And this plus minus get cancelled. And hence y square plus dy by dx is equals to 0. Hence once again see this. This was the problem about the t that I had committed it. This is a dx upon dt is a minus 2 upon 1 minus t bracket square. And hence this is the proof. Now the next is the next question. Therefore y square is equals to t minus 1 bracket square upon t plus 1 bracket square. Hence dy by dx plus y square, that is a y square plus dy by dx, that is a t minus 1 bracket square upon t plus 1 bracket square minus t minus 1 bracket square upon t plus 1 bracket square, and that's equals to 0 y square plus dy by dx, that is equals to 0 y square. Next is fourth one. If x is equals to a cos cube t, y is equals to a sin cube t, then show that dy by dx is equals to minus y upon x bracket raised to 1 upon 3. Now x is equals to a cos cube t, y is equals to a sin cube t. Therefore x upon a is equals to cos cube t, y upon a is equals to sin cube t. Simple. You can write down. Take cube root on both sides. That is a cos t is equals to x upon a raised to 1 upon 3. Sin t is equals to y upon a raised to 1 upon 3. Therefore sin square t plus cos square t, that is equals to x upon a raised to 1 upon 3 plus y upon a raised to 1 upon 3. Therefore, that is 1 is equals to y upon a raised to 2 upon 3 plus x upon a raised to 2 upon 3. X upon a raised to 2 upon 3 plus y upon a raised to 2 upon 3, that is equals to 1. Now differentiate this with respect to x. Then you will get 2 upon 3 into x upon a raised to 2 upon 3 minus 1 plus 2 upon 3 y raised to 2 upon 3 minus 1 into dy by ddx of one thing, I think that remaining there. That's the derivative of y upon a. Derivative of x upon a is 1 upon. On the both sides that will get, I think, cancelled. I will show you again. Now see this problem only first of all. There will be a problem of a. Y upon a plus, and here is again plus. Therefore dy by dx is equals to now I will correct now that problem. This x is equals to a cos cube t, y is equals to a sin cube t, x upon a is equals to cos cube t, and y upon a is equals to sin cube t. Therefore, cos t is equals to x upon a raised to 1 upon 3 and sin of t is equals to y upon a bracket raised to 1 upon t. Therefore, sin square t plus cos square t. Now here is a 1 is equals to y upon a raised to 2 upon 3 plus x upon a raised to 2 upon 3. X upon a raised to 2 upon 3 plus y upon a raised to 2 upon 3 is equals to 1. Now differentiate this with respect to x, that is a 2 upon 3, x upon a raised to 2 upon 3 minus 1 into derivative of x upon a is 1 upon a plus 2 upon 3 into y upon a raised to 2 upon 3 minus 1 into derivative of y upon a is equals to 0. That is x raised to x upon a raised to minus 1 upon 3 into 1 upon a plus y upon a raised to minus 1 upon 3 into 1 upon a into dy by dx is equals to 0. This 1 upon a and 1 upon a get cancelled on both sides, and that's why you are getting the answer, that is a dy by dx is equals to minus x upon a raised to minus 1 upon 3 upon y upon a raised to minus 1 upon 3. We can make their powers positive by interchanging their numerators and denominators. That is a dy by dx is equals to y upon a minus y upon a raised to 1 upon 3 upon x upon a raised to 1 upon 3. This a get cancelled, you will get dy by dx is equals to minus y upon x raised to 1 upon 3, and hence it is approved. Next is fifth one. If x is equals to 2 cos raised to 4 in bracket t plus 3, y is equals to 3 sin raised to 4 in bracket t plus 3, that is x upon 2 cos raised to 4 in bracket t plus 3 y upon 3 sin raised to 4 in bracket t plus 3. Now next is cos square t plus 3 is equals to in root of x upon 2 sin square t plus 3 is equals to in root of y plus 3. Now sin square t plus 3 plus cos square t plus 3, that is equals to in root of x upon 2 plus in root of y upon 3. So value is 1. Therefore in root of x upon 2 plus in root of y upon 3, that is equals to 1. Now differentiate this with respect to x. Derivative of root of x upon 2, that is 1 upon 2 in root of x upon 2 into derivative of x upon 2 plus 1 upon root of y upon 3, that is 1 upon 2 root of y upon 3 into ddx of y upon 3, that is equals to 0. Now overall 2 get cancelled, then you will get 1 upon in root of x upon 2, derivative of x upon 2 is 1 upon 2 plus 1 upon in root of y upon 3 into 1 upon 3 into dy by dx, that is equals to 0. And therefore, that is this can be written as, that is the root of 2 upon 3 into 1 upon 2 plus root of 3 upon y into 1 upon 3 into dy by dx, that is equals to 0. Now see this term. Now we will find the value of the dy by dx, that is root 3. This is the root 1 upon 3, root of 3 upon y into dy by dx is equals to minus 1 upon 2 in root of 2 upon x. Therefore dy by dx is equals to minus 1 upon 2 3 minus 1 upon 2 3 in root of 2 upon x in root of y upon root 3. Now therefore dy by dx is equals to minus 3 by 2 in root of 2 upon 3 into y upon x. That the both of them have the root sign. Therefore, it is a minus 3 by 2 and dy by dx is equals to now see this again. There is a small, that is a 9 by 4. When this 3 upon 2 goes into a radicand side, it becomes it's a square, which is a 9 by 4 into 2 upon 3. And now simplify this. Therefore, you will get, that is 3 upon 2 root of 3 upon 2 y upon x. Therefore, dy by dx is equals to minus root of 3 upon 2 y upon x. Hence proved. Now see this again here. X upon 2 y upon 3 cos raised to 4t plus 3 sin raised to 4t plus 3. Take their square root, add them. Then you will get a root of x upon 2 plus root of y upon 3 is equals to 1. And now differentiate it. Then you will get 1 upon 2 root of x upon 2. Derivative of x upon 2 is 1 upon 2. 1 upon 2 in root of y upon 3 into ddx of y upon 3. That is 1 upon 3 into dy by dx is equals to 0. Therefore, this is a root of 2 upon x into 1 upon 2 plus root of 3 upon y into 1 upon 3 into dy by dx is equals to 0. Therefore, 1 upon 3 in root of y upon 3 into dy by dx is equals to minus 1 upon 2 in root of 2 upon x. And that's why dy by dx is equals to minus 3 upon 2 in root of 2 upon 3 y upon x. And therefore, dy by dx is equals to minus in root of 9 upon 4 into 2 upon 3 into y upon x. Therefore, dy by dx is equals to minus in root of 3 by 2 into y upon x. Therefore, dy by dx is equals to minus in root of 3 upon 2 into y upon x. Now the next is sixth one. If x is equals to 1 plus t square, y is equals to t minus tan inverse of t, then show that dy by dx is equals to in root of e raised to x minus 1 upon 2. X is equals to log of 1 plus t square, y is equals to t minus tan inverse of t. Now differentiate this with respect to its derivative of log of 1 plus t square means what? 1 upon 1 plus t square into derivative of 1 plus t square. Derivative of 1 is 0, t square is a 2t. Therefore, dx upon dt is equals to also we will convert this first in terms of the exponential power. That is answer in the exponential power. That is e raised to x is equals to 1 plus t square. E raised to x is equals to 1 plus t square. Now differentiate this. Now what is the derivative of e raised to x is e raised to x into dx upon dt. Derivative of 1 is 0, t square is a 2t. Now dy by dt into derivative of t is 1, tan inverse of t is 1 upon 1 plus t square. E raised to x into dx upon dt is equals to 2t. dy upon dt is equals to 1 minus 1 upon 1 plus t square. Therefore, dx upon dt is equals to minus, that is the 2t upon dx upon dt is equals to 2t upon e raised to x, and dy by dt is equals to, simplify this, that is 1 plus t square minus 1 upon 1 plus t square. Normal simplification is here. Plus 1 and minus 1 get cancelled. T square upon 1 plus t square. Therefore, dx upon dt is equals to 2t upon e raised to t, and dy by dt is equals to t square upon 1 plus t square. Therefore, dy by dx is equals to dy by dt upon dx upon dt, and that is equals to t square upon 1 plus t square upon 2t upon e raised to x. And therefore, after simplification, you will get dy by dx is equals to t square upon 1 plus t square into e raised to x upon 2t. Therefore, dy by dx is equals to t square upon 1 plus t square 2t upon 1 plus 2t upon 1 plus t square. And after simplifying, you will get, because we are substituting the value of e raised to x. E raised to x is 1 plus t square. Now 1 plus t square from the numerator and denominator get cancelled. T square upon 2t. That is 1t will get cancelled. That is the t upon t. Therefore, dy by dx is equals to t upon t. Now again, find out the value of t. But e raised to x is equals to t square plus 1. Therefore, e raised to x minus 1 is equals to t square. Therefore, t is equals to in root of e raised to x minus 1. T is equals to e raised to x minus 1, and our answer is dy by dx is equals to t by 2. Substitute the value of that t, e raised to x minus 1 upon 2. This is the dy by dx in root of e raised to x minus 1 upon 2. Next is, again see this, x is equals to log of 1 plus t square, y is equals to t minus tan inverse of t. Then dy by dx is very complicated, that is in root of e raised to x minus 1 upon 2. Now x is equals to log of 1 plus t square, y is equals to t minus tan inverse of t. I had started the derivative, but it is not the case. Now here the answer contains e raised to x. Therefore, this logarithmic function can be converted into the exponential. Therefore, e raised to x is equals to 1 plus t square and y is equals to t minus tan inverse of t. Now differentiate this with respect to t. Derivative of e raised to x is e raised to x into dx upon dt. Derivative of 1 is 0, t square is 2t. Derivative of y is a dy by dt. Derivative of t is 1. Tan inverse of 2t is 1 upon 1 plus t square. Therefore, it is a e raised to x into dx upon dt is equals to 2t. dy by dt is equals to 1 minus 1 upon 1 plus t square. Therefore, dy by dt is equals to 1 plus t square minus 1 upon 1 plus t square. Therefore, dx upon dt is equals to 2t upon e raised to x. And dy by dt is equals to t square upon 1 plus t square. Therefore, dy by dx is equals to dy by dt upon dx upon dt. Now simplify this. What is the dy by dt? Dy by dt is a t square upon 1 plus t square. And dx upon dt is a 2t upon e raised to t. Now what's happening here? Dy by dx is equals to t square upon 1 plus t square and whole divided by 2t upon 1 plus t square. Now this 1 plus t square, 1 plus t square get cancelled. Because here is not e raised to x. But where is e raised to x? That is the value of the e raised to x is a 1 plus t square. And that's why After the cancellations, you will get t upon 2. But again, what is the value of the t? The value of the t is, we can find out by using the e raised to x is equals to t square plus 1. That is e raised to x minus 1 is equals to t square. Therefore, t is equals to in root of e raised to x minus 1. And that's why dy by dx is equals to t upon 2. And the value of the t is in root of e raised to x minus 1. Therefore, dy by dx is equals to in root of e raised to x minus 1 upon 2. And hence, it is a proof. Now, the next is seven. If x is equals to sine inverse of e raised to t, therefore sin x is equals to e raised to t, y is equals to now normal differentiation is here. X is equals to sine inverse of e raised to t. What's its a derivative? Dx upon dt is equals to derivative of sine inverse of x is 1 upon in root of 1 minus x square. In same manner, 1 upon in root of 1 minus e raised to t bracket square into derivative of e raised to t, which is e raised to t. Therefore, see this here. Therefore, dx upon dt is equals to e raised to t upon in root of 1 minus e raised to 2t. What about the y? Y is equals to in root of 1 minus 2t now differentiate this with respect to t. That is dy by dt is equals to 1 upon 2 times in root of 1 minus e raised to 2t into derivative of 1 minus e raised to 2t. That is a minus. Now see this here. Derivative of 1 is 0. What is the derivative of e raised to 2t? Derivative of e raised to 2t is e raised to 2t into derivative of 2t, which is 2. And there is a minus. Now these 2 get cancelled. Then you will get e raised to 2t upon in root of 1 minus 2t. 1 minus e raised to 2t. Therefore, dy by dt is equals to minus e raised to 2t upon in root of 1 minus e raised to 2t. Therefore, dy by dx is equals to dy by dt upon dx upon dt. Substitute the values. That is a minus e raised to 2t upon in root of 1 minus 2t upon e raised to t in root of 1 minus e raised to 2t. That get cancelled. Therefore, you will get minus e raised to 2t upon e raised to t. That is e raised to minus e raised to 2t minus 1. That is a minus e raised to t. Therefore, dy by dx is equals to minus e raised to t. Now e raised to t plus dy by dx, that is equals to 0. Because therefore sin x plus dy by dx is equals to 0. And that's why I had found the value of that sin of x, that is this is the hence proof. Now see this again. Same. X is equals to sine inverse of e raised to t, y is equals to in root of 1 minus e raised to 2t, sin x plus dy by dx is equals to 0. X is equals to sine inverse of e raised to t. Therefore, sin x is equals to e raised to t. This is first. Now differentiate this, regular differentiation. I will scroll down, you can write down. Therefore, dy by dx is equals to minus e raised to t. Therefore, e raised to t plus dy by dx is equals to 0. But what is the value of e raised to t? Just e raised to t is a sin x. Therefore, sin x plus dy by dx is equals to 0, and hence it is approved. Now the next is eighth one. If x is equals to 2bt upon 1 plus t square, y is equals to a in root of 1 minus t square upon 1 plus t square, then show that dy by dx upon dy is equals to minus b square y upon a square x. Very important as well as complicated. Now x is equals to 2bt upon 1 plus t square, and y is equals to a in bracket 1 minus t square upon 1 plus t square. These are the parameters of the ellipse. Parameters in the sense that is, if we square and add it, then you will get 1. That is a squaring and adding, that is x upon, now see this, very important, this problem is, that is x upon b is equals to 2t upon 1 plus t square, and y upon a is equals to 1 minus t square upon 1 plus t square. Therefore, squaring and adding, x square upon b square plus, that is 4t square upon 1 plus t square bracket square, and y square upon a square is equals to 1 minus t square bracket square upon 1 plus t square bracket square. That is x square upon x square upon b square plus y square upon a square. It's a very common formula for the ellipse, but here is not that a. X square upon b square plus y square upon b square is equals to, see this, x square upon b square plus y square upon a square is equals to, the value of x square upon b square is 4t square upon 1 plus t square bracket square plus y square upon a square 1 minus t square bracket square upon 1 plus t square bracket square. Now simplify this. That is a 4t square plus 1. That is a 1 minus t square. Expand this. 1 minus 2t plus t raised to 4 upon 1 plus t square bracket square. Now here is a 1 plus 2t square plus t raised to 4. It's a mistake. By mistake, it's a bracket square. Now it's a bracket square. That is 1 plus 2t square plus t raised to 4. This is not required. That is 1 plus t square. It's a bracket square now. Upon 1 plus t square and bracket square. By mistake, I had written it. You can understand that is x square plus x square upon b square plus y square upon a square is equals to, that is equals to 1. Therefore, x square upon b square plus y square upon a square is equals to 1. And therefore, differentiate this with respect to x. What is the derivative of x square? Is that 2x upon b square plus 2y upon a square into dy by dx is equals to 0. Therefore, dy by dx that is, this 2 will get cancelled. Y upon a square into dy by dx is equals to minus x upon b square. Therefore, dy by dx is equals to minus x upon b square into a square upon y, and that is dy by dx is equals to minus x a square upon yb square. Therefore, dx upon dy is equals to minus yb square upon x a square, and this is the final answer. Now see this again, once again. You can remove this. This is x upon b, 2t upon 1 plus t square, y upon a, 1 minus t square upon 1 plus t square, squaring and adding. I will scroll down, you can write down. This is not the square, it is not necessary. My mistake, I have taken it. Okay. Next is bracket square. Now differentiate this. Therefore dy by dx is equals to minus x a square upon y b square, and hence this is the proof. Next is question number 4. Differentiate x sin x with respect to tan x. Now differentiate this. X is a function of, or u is a function of x, v is a function of x. Now differentiate with respect to x. du by dx, apply the product rule. Now see this here. That is the x, derivative of sin x is cos x. Sin x, derivative of x, that is 1. I have written that. Next is dv by dx, derivative of tan is a sec square x. Therefore du by dx is equals to x cos x plus sin x, and dv by dx is equals to sec square x. Therefore dy by du by dv is equals to du by dx upon dv by dx, and that's why substitute the value. X cos x plus sin x upon sec square x du by dv. Therefore du by dv is equals to x cos x plus sin x upon sec square x. Very simple. We'll find out the number of the derivatives. Therefore you can solve this. Du upon dv is equals to x cos x plus sin x upon sec square x. Next is, I will scroll down, you can write the answer. Now the next is question number 2. Differentiate sine inverse of 2x upon 1 plus x square. This is a very famous problem. With respect to cos inverse of 1 minus x square upon 1 plus x square. Therefore, now u is equals to sin inverse of 2x upon 1 plus x square. Very common substitution. X is equals to tan theta. Theta is equals to tan inverse of x. Therefore, u is equals to sin inverse of 2 tan theta upon 1 plus tan square theta, and that is nothing but the tan of sine of 2 times theta. If we simplify that, you will get 2 tan theta upon 1 plus tan square theta. This is the sine of 2 times theta. Now, sine inverse of sine of 2 times theta is 2 theta. Therefore, u is equals to 2 theta. Now I can differentiate this with respect to theta. Therefore, du by, or substitute the values, 2 tan inverse of x, du by, with respect to du by dx is equals to 2 upon 1 plus x square. Next is v is equals to cos inverse of 1 minus x square upon 1 plus x square. That is the cos inverse of 1 minus tan square theta upon 1 plus tan square theta. That is the cos inverse of cos of 2 times theta. This is the formula, 1 minus tan square theta upon 1 plus tan square theta. If we simplify, you will get cos of 2 times theta. Therefore, v is equals to 2 theta. That is equals to 2. Theta is the tan inverse of x. And now differentiate again this with respect to x. dv upon dx is equals to 2 upon 1 plus x square. dv upon dx is equals to 2 upon 1 plus x square. Therefore, our required derivative du by dv is equals to du by dx upon dv by dx. Therefore, 2 upon 1 plus x square upon 2 upon 1 plus x square, and hence the answer is 1. du by dx is equals to 1. Now the next is, I will scroll down this, you write down the answer from this board. Next is differentiate tan inverse of x upon in root of 1 minus x square with respect to sec inverse of 2x square minus 1. That is the tan inverse of x upon in root of 1 minus x square. This is x square. Now here is a u is equals to v is equals to now here that is a v is equals to sec inverse in bracket 1 minus 2x square minus 1. This can be converted into the cos. That is v is equals to cos inverse in bracket 2x minus 1. U is equals to tan inverse x upon in root of 1 minus x square. and v is equals to cos inverse 2x square minus 1. Now here substitution, x is equals to sin theta, and therefore theta is equals to sin inverse of x. Now u is equals to tan inverse of sin theta upon in root of 1 minus sin square theta, and v is equals to cos inverse in bracket 2 sin square theta minus 1. Therefore, u is equals to, you will get sin theta upon in root of 1 minus sin square theta. But what is 1 minus sin square theta? Is a cos square theta, and root get cancelled, you will get cos theta. That is a sin theta upon cos theta, that is equals to tan theta. That is a tan inverse of tan of theta, which will become theta. What about here? That is a cos inverse of 2 sin square theta minus 1. This is nothing but the cos of 2 times theta. Therefore, u is equals to tan inverse of sin theta upon cos theta, and v is equals to, that is a tan inverse of tan of theta, and that is a v is equals to cos inverse of that is 1 minus 2 sin square theta. We have taken the common, that is a minus sign is common. Therefore, that is a cos of 2 times theta is a 1 minus 2 sin square theta. Therefore, u is equals to theta, and v is equals to cos inverse of minus cos of 2 times theta. That is nothing but the pi minus cos inverse of 2 times theta. Now cos inverse of 2 times theta means what? This is the 2 theta. Therefore, u is equals to theta and v is equals to pi minus 2 theta. Now substitute the value of theta. Theta is a sin inverse of x. Theta is sin inverse of x. Therefore, du by d theta is 1, dv by d theta is a minus 2. Therefore, du upon dv is equals to du upon d theta upon dv upon d theta. That is a 1 upon minus 2. And hence, the answer is du upon dv is equals to minus 1 upon 2. Now, also you can write down this from the board. Now differentiate this with respect to one with respect to the other. Substitution is important. You will get u is equals to tan theta. Now this is also important. That is a, take the minus sign as common. Then in bracket you will get minus 1 minus 2 sin square theta. But what is the 1 minus 2 sin square theta? That is nothing but the cos of 2 times theta. Now cos inverse of minus cos of 2 times theta is a pi minus cos inverse of 2 theta. Therefore, v is equals to pi minus 2 theta. Now differentiate this with respect to theta. Well, we have to substitute the value of that theta, but instead of that, we have find out this. It doesn't difference in answer. Therefore, du by dv is equals to minus 1 upon 2. Now the next problem is number 4. Differentiate cos inverse of 1 minus x square upon 1 plus x square with respect to tan inverse of x. That is, u is equals to cos inverse in bracket 1 minus x square upon 1 plus x square, and v is equals to tan inverse of x. Now put x is equals to tan theta. Then in bracket you will get cos inverse of in bracket 1 minus tan square theta upon 1 plus tan square theta. And this is nothing but again, that is the tan inverse of tan of theta. And we have again the formula That is 1 minus tan square theta upon 1 plus tan square theta. This is nothing but the cos of 2 times theta. Therefore, cos inverse of cos of 2 times theta and V is equals to tan inverse of tan of theta, that is the theta. Now E is equals to 2 theta, V is equals to theta, differentiate again with respect to theta. It doesn't different any answer. Therefore, du upon d theta is equals to 2 and dv upon d theta, that is equals to 1, and therefore du upon dv is equals to du upon d theta upon dv upon d theta, and that is equals to 2 upon 1, that is equals to 2. Therefore, du by dv is equals to 2. Now the next is fifth one. You can see this and I will scroll down and you can write the answer of this. U is equals to cos inverse in bracket 1 minus x square upon 1 plus x square. V is equals to tan inverse of x. X is equals to tan theta. Therefore, you will get U is equals to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. U is equals to cos inverse of cos of 2 times theta and V is equals to theta. U is equals to 2 theta and V is equals to theta. Differentiate this with respect to theta. Du upon d theta is 2 and dv upon d theta is 1. Therefore, du upon dv is equals to du upon d theta upon dv upon d theta. That is a 2 upon 1. That is a du upon dv. That is equals to 2. Now the next is fifth. Differentiate 3 raised to x with respect to log of 3 to the base x. Log of 3 to the base x. Now u is equals to 3 raised to x, and this is important. V is equals to log of 3 to the base can be written as log of 3 upon log of x. Now differentiate this with respect to here, doesn't require any substitution. Therefore, differentiate this with respect to x. What is the derivative of 3 raised to x? The derivative of 3 raised to x is 3 raised to x into log of 3. And dv by dx. Now log of 3 is a constant, that is a 1 log of 1 upon x. 1 upon log x is this derivative is important. That is 1 upon log x. That is 1 upon v. Its a derivative is a minus 1 upon v square into derivative of v. In a same manner, that is a 1 upon minus 1 upon log of x bracket square into derivative of log of x. What's the derivative of log of x? Is a 1 upon x. Now see this here. Therefore, du by dx is equals to 3 raised to x log of 3 and dv by dx is equals to minus log of 3 upon, what is here? This is a log of x, its a derivative of 1 upon x. Therefore, minus log of 3 upon x log of 3 log of x bracket square. Therefore, du by dv is equals to 3 raised to du upon dx upon dv upon dx, that is a 3 raised to x log of 3 upon minus log of 3 upon x into log of x bracket square. If we simplify this, then you will get du upon dv is equals to 3 raised to x into log of 3 into x upon log of x bracket square upon log of 3. Now this log of 3 get cancelled and you will get 3 raised to x into x log of x bracket square. This is the du by dv and hence. Du by dv is equals to 3 raised to x into log of x bracket square. Now see this, write down this example. I will scroll down this. 3 raised to x with respect to log of 3 to the base x. U is equals to 3 raised to x. Log of, that is v is equals to log of 3 to the base x, log of 3 upon log of x. Therefore, differentiate this with respect to x. Derivative of 3 raised to x is 3 raised to x into log of 3, and dv by dx is equals to log of 3. What is the derivative of 1 upon log x? That is a minus 1 upon log x, bracket square into derivative of log of x. Therefore, dv by dx is equals to minus log of 3 upon derivative of log of x is a 1 upon x into log of x, a bracket square. And that's why you will have du by dv is equals to du by dv upon dv by dx. That is equals to 3 raised to x into log of 3 upon minus log of 3 upon x log of x, bracket square. And if we simplify this, then you will get minus 3 raised to x log of 3 into x log of x, bracket square, upon log of 3. This log of 3 get cancelled, and then you will get du by dv is equals to minus 3 raised to x into x log of x, bracket square. Now the next example. That is example number 6. Differentiate tan inverse of in bracket cos x upon 1 plus sin x. This is again very interesting problem. That is the tan inverse of in bracket cos x upon 1 plus sin square x with respect to sec inverse of x. Now tan inverse of in bracket cos x upon 1 plus sin square x. V is equals to sec inverse of x. Now tan inverse of, now this cos x can be written as cos square x by 2 minus sin square x by 2, and 1 plus sin x can be written as cos of x by 2 plus sin of x by 2 whole bracket square, and V is equals to sec inverse of x. Now here is a 1, that is a square minus b square, that is a tan inverse of cos of x by 2 minus sin of x by 2 in one bracket, and another bracket plus. That plus will get cancelled, and that's why you will get, that is a tan inverse of cos of x by 2 minus sin x by 2 upon, I am writing again next step also, that is the cos of x by 2 plus sin of x by 2. This 1 power of cos of x by 2 plus sin of x by 2 will get cancelled, and V is equals to sec inverse of x. Now again we have solved this type of examples, that is a tan inverse of cos of x by 2 minus sin of x by 2 upon cos of x by 2 plus sin of x by 2. Now divide the numerator and the denominator by cos of x by 2. That's why you will get tan inverse of in bracket 1 minus tan of x by 2 upon 1 plus tan of x by 2. And V is equals to sec inverse in bracket sec inverse of x. Now again this is the expansion of 1 minus tan of x by 2 upon 1 plus tan of x by 2, and that is nothing but tan of pi by 4 minus tan of x by 2 upon 1 plus tan of pi by 4 into tan of x by 2. Continue writing of the V is equals to sec inverse of x, and finally we take the derivative. That is a tan inverse of tan of pi by 4 minus x by 2. That is a tan inverse of tan of pi by 4 minus x by 2 is equals to pi by 4 minus x by 2. Now differentiate this with respect to x. That is u is equals to pi by 4 minus x by 2, and v is equals to sec inverse of x. Differentiate this with respect to x. Therefore, du upon dx is equals to derivative of pi by 4 is 0 and derivative of x is 1, and overall you are getting the minus 1 upon 2. And dv by dx is equals to sec inverse. What is the derivative of sec inverse? That is 1 upon x in root of x square minus 1. Therefore, our required derivative is, that is a du upon dv is equals to du by dx upon dv by dx. That is minus 1 upon 2 minus 1 upon 2 whole divided by 1 upon x root of x square minus 1. and it becomes multiplied and reciprocal, that is minus 1 upon 2 into x in root of x square minus 1, and therefore du by dv is equals to, that is a minus x in root of x square minus 1 upon 2, and this is the final answer. Now you can write down this. I will summarize this problem. Sixth one, I will scroll down. You can write down u is equals to v is equals to, apply the formula, you can write down from this board. U is equals to pi by 4 minus x by 2, v is equals to sec inverse of x, their derivatives. This is the answer. Now the next is seventh problem. Differentiate x raised to x with respect to x raised to sin x. Now we have find out the derivative of x raised to x number of the times, that is the in exercise 1.3. This is function raised to function. Take log on both sides. Therefore you will get log of u is equals to, take log on both sides. Therefore log of u is equals to x log x, and log of v is equals to sin x log of x. Now differentiate this with respect to x. Therefore you will get 1 upon u into du by dx. Apply the product rule, that is the x into log x. That is, first is x, the derivative of log of x is 1 upon x. Then derivative of x is 1 into log of x. Now these x get cancelled. That is the 1 plus log x. Therefore you will get du 1 upon u into du by dx is equals to 1 plus log x, and therefore du by dx is equals to u into in bracket 1 plus log x, that is du by dx is equals to x raised to x in bracket 1 plus log x. Very famous derivative. Now next is x raised to sin x. Now log of v is equals to sin x into log of x. Now differentiate this again with respect to x. Therefore 1 upon v into dv by dx, apply the product rule, sin x into derivative of log of x is 1 upon x plus log of x into derivative of sin of x, which is the cos of x. Therefore dv by dx is equals to v into in bracket sin of x upon x plus log of x into cos of x. Substitute the value of v. What is the v? V is x raised to sin x. Therefore the required derivative is x raised to x in bracket 1 plus log x upon, to the denominator x raised to sin x in bracket sin of x upon x plus log of x into cos x. Sin of x upon x plus log of x into cos x. This is the answer. Again we can simplify. This is x raised to x and upon x raised to sin x. It may be written as that is x raised to x minus sin x. Therefore, du upon dv is equals to x raised to x in bracket 1 plus log x upon x raised to sin x in bracket sin x upon x, or simplify it, sin x plus x log of x upon cos x upon x. It's a multiplied and reciprocal, that will become, and therefore du upon dv is equals to x raised to 1 plus sin x, x raised to x minus sin x plus 1 I'm making mistakes. This is not possible. I will show you again. That is x raised to x, v raised to x is equals to v is equals to x raised to sin x. Take log 1 upon u du by dx is equals to x log x. X derivative log of x is 1 upon x plus derivative of x is 1 into log x. Therefore, 1 upon u into du by dx is equals to 1 plus log x. Therefore, du by dx is equals to u into in bracket 1 plus log x. But what is u? U is x raised to x. Therefore, du by dx is equals to x raised to x in bracket 1 plus log x. Next is log of v is equals to sin x into log x. And it's a differentiate with respect to x. 1 upon v into dv by dx is equals to sin x log of x derivative is 1 upon x plus log of x into derivative sin of x is a cos x. Therefore, dv by dx is equals to v into sin of x upon x plus log of x into cos x. Therefore, required derivative is a du by dv is equals to x raised to x into 1 plus log x upon x raised to sin x into in bracket sin of x upon x plus log of x into cos x. And if we simplify this, then you will get, that is a du by dv is equals to x raised to x in bracket 1 plus sin x into x upon sin x, x raised to sin x in bracket sin of x plus x log of x into cos x. Now see this again, and this is the final answer, that is a du by dv is equals to x raised to x sin x plus 1 upon sin x plus x cos x into log x. And now the next problem, that is the last problem from this exercise, problem number 8. Differentiate tan inverse in bracket in root of 1 plus x square minus 1 upon x with respect to tan inverse of 2x in root of 1 minus x square upon 1 minus 2x square. Now put x is equals to tan theta. Therefore, u is equals to tan inverse of in root of 1 plus tan square theta minus 1 upon tan theta. That is u is equals to tan inverse 1 plus tan square theta, that is a sec square theta, which is sec theta minus 1 upon tan theta. And now if we simplify, you will get, what is a sec? Sec means what? 1 upon cos. That 1 upon cos minus 1 means what? 1 minus cos theta upon cos theta. And what is the tan theta? Sin theta upon cos theta. Therefore, that cos theta will get cancelled. Then you will get 1 minus cos theta upon sin theta. Now see this. 1 upon 1 minus cos theta minus 1. Simplify this. Therefore, 1 minus cos theta upon cos theta. Sin theta upon cos theta. Therefore, u is equals to tan inverse of, in bracket, 1 minus cos theta upon sin theta. That is a tan inverse of, in bracket, what is 1 minus cos theta? that is a 2 sine square x upon 2. And what is the sine theta? I think that there is both of them have theta. Here is a theta. By mistake it is, that is a 2 sine square theta upon 2. What is the sine theta? 2 sine theta by 2 into cos theta by 2. It is that is a 2 sine square. It must be theta. Therefore 2 sine square theta by 2. 2 sine theta by 2 into cos theta by 2. Now 2 get cancelled. Sine theta by 2, theta by 2 get cancelled. That is u is equals to tan inverse of tan of theta by 2. That's the tan inverse of tan of theta by 2 is equals to u is equals to 1 upon 2 into theta. Now next is 1 upon 2 into tan inverse of x. This is our u. Now next is differentiate this with respect to x. Then you will get du by dx is equals to 1 upon 2, 1 upon 1 plus x square. Derivative of tan inverse of x is 1 upon 1 plus x square. Now v is equals to tan inverse 2x in root of 1 minus x square upon 1 minus 2x square. That x is equals to sine theta and theta is equals to sine inverse of x. Therefore, v is equals to tan inverse of 2 sine theta in root of 1 minus sine square theta upon 1 minus 2 sine square theta, and hence in bracket you will get tan inverse of 2 sine theta into, that is, see this here, in root of 1 minus sine square theta is a cos square theta, root get cancelled, you will get cos theta, and 1 minus 2 sine square theta, and this is nothing but the cos of 2 times theta. Now again this is very interesting, that is a v is equals to tan inverse of tan of 2 times theta. There is a 2 sine theta into cos theta means what? Sine of 2 times theta, and sine of 2 times theta upon cos of 2 times theta is a tan of 2 times theta. Tan inverse of tan of 2 times theta is equals to 2 theta, and therefore v is equals to 2 sine inverse of x. Now differentiate this with respect to x, then you will get 2 upon in root of 1 minus x square, and that's why du upon dv is equals to, that is 1 upon 2 in 1 upon 2 in bracket 1 plus x square upon 2 upon in root of 1 minus x square, and that's if you multiply and reciprocal, then you will get du upon dv is equals to 1 upon 2 in bracket 1 plus x square into in root of 1 minus x square upon 2, and that is a du upon dv is equals to in root of 1 minus x square upon 4 in bracket 1 plus x square. If you want to write down this, you can have u is equals to tan inverse of in root of 1 plus tan square theta minus 1 upon tan theta. U is equals to 1 upon 2 tan inverse of x. It's a derivative du by dx is equals to 1 upon 2 into 1 upon 1 plus x square. Same case, v is equals to tan inverse of 2x in root of 1 minus x square upon 1 minus 2x square. Put x is equals to sin theta, theta is equals to sin inverse of x. And that's why numerator and denominator you are getting the tan of 2 times theta. Therefore, v is equals to 2 theta. V is equals to 2 sin inverse of x. and dv upon dx is 2 upon in root of 1 minus x square. Therefore, du upon dv is equals to 1 upon 2 in bracket 1 plus x square upon 2 upon in root of 1 minus x square. And that's why this is the du upon dv. And in this way, we have completed the exercise 1.4. I hope that you will have understood all the problems, whatever that I had explained. Now we will see in the next video. Till then, goodbye.